Thank you very much, Brendan. So I'm not actually going to start off talking about oceanography. I'm going to talk about meteorology, because actually that's where it all starts. Or does it? That's a bit contentious. Okay, so many thanks indeed. My name is Tim Smyth. I am Head of Science for Marine Biogeochemistry and Observations here at PML. And part of my job is looking after the Western Channel Observatory, which I shall talk in great depth about in a moment. So first of all, what is the Western Channel Observatory? Well, the Western Channel Observatory is a set of long-term time series stations. So you're sat somewhere off the top there. I don't think the pointer's working particularly well, so we might need to go. There we go. So you're up here. And the key stations here are outlined in red. So station L4, which is 4 nautical miles due south of Rame Head in about 50 metres deep of water. And then station E1, which the MBA and ourselves have been sampling since 1903. So that's about 20 nautical miles due south of Rame Head in about 80 metres deep of water. Very different in characteristics, these two stations. This station L4 is much more coastally influenced. E1 is much more open shelf influence. And the change occurs around the notorious Eddystone Reef. We don't just observe the water column. We established about 10 years ago now an atmospheric sampling station at Penley Point. So this is the Trinity House hut. If you go walking around the coastline, you'll know it well. And we've populated that with lots of instrumentation. So we measure things like eddy covariance fluxes of gases like carbon dioxide, methane, nitrous oxide, that kind of thing. Our two main pelagic stations, so this is sampling in uncharacteristically calm weather off the back of the Quest. So this is our staple sampling equipment, which is the CTD Rosette sampler. So on here you've got bottles that can take discrete samples at different depths. And then we've got electronic instrumentation here, commonly known as the CTD. So conductivity, temperature with depth, and you can determine the temperature and the salinity with depth with that instrumentation. So I've already mentioned L4 and E1. And finally, we have the very important seafloor measurements, so the benthic measurements at 4 stations. So Jennycliff, Coarse Sand, Rame, Mud, and just southeast of L4. So we generally use things like box corer to sample the marine environment there. So just to give you an idea that we're sampling the entirety of the system within the Western Channel Observatory, and there's a lot of commonalities and fluxes, etc., which is a talk probably for another day. So now I'm going to talk a little bit about the meteorology, and the next 5 slides are really what happened during 2022. So each of the next 5 slides is going to be very similar in appearance. So on the left-hand side of every slide, there is what the UK-wide temperature was doing in terms of anomalies. So this is anomaly from the climatological mean from 1991 to 2020. And basically where you've got the warmer colours, that's where you've got sort of positive anomaly. In the middle, rainfall amount. Now, why do you think why am I mentioning rainfall? Well, rainfall is absolutely critical for driving what happens in the Western English Channel because of the riverine outflow and into the channel. So that can give us really good indicators about what's going on in terms of circulation patterns, for example. So in the middle, you've got the rainfall amount, and basically where it looks dry, then it is dry, increasingly dry. And then sunshine duration, so where it's duller, it's sort of greyer. Okay, so that's kind of a orientation. And then in the middle, what I'll flash up at the end is then what the mean temperature has done. So this is for the UK as a whole. There will be regional differences, but this is really helpful to look at. And actually, the next few slides make it even better to look at these days, because this is all from the Met Office. You can download all these data, are all freely available. So please go and look at that after the presentations if you're interested. In the middle, you've got the mean. So that's what an average winter looks like, around about 4 to 5 degrees on average. And then this is actually what happened is for 2022. So this is the winter for 2022. So this is December 2021 through to January, February 2022. And you can see pretty much you're always on the high side. So that shows that we had a winter down here that was around about 1 to 1.5 degrees milder. The rainfall, as you will know, if your hose pipe is banned from being in use, then it was a very dry winter. So we had somewhere between 70 to 90% of average rainfall down here. And then last winter, or the winter before last, if you can cast your mind back, was actually just below the average in terms of sunshine duration. So periods to note, just as we were coming into 2022, there was this much, a very mild period where we were getting temperatures maybe 4, 5, 6 degrees warmer than average. So you'll see this as time goes on. So then moving forward into spring, again, spring kind of continued that trend down here. So we had temperatures somewhere between 0.5 degree and 1 degree milder than average. Again, a very dry spring. I think we're now somewhere between 50 to 70% of average rainfall. Again, that impacts things like the Tamar River, the amount of water that's going in there and then flushing out into the English Channel and all the other river systems that affect the area. And it was a pretty average spring in terms of sunshine. Now this is great. I really like that the Met Office has just taken on this. Now you can really easily see where we're getting these anomalies away from the mean. So, just very quickly at a glance, you can see that spring last year was, we had these very mild interludes, but actually we had a couple of, in late March, early April, we had some pretty cold weather as well. And then as we went into late May, there was probably the Platinum holiday. I think it was particularly cold and cheerless as usual. Right, so anyway, moving on to summer. I haven't managed to do this very well, but we could just about see down below here what's going on down in the southwest. So we were, again, it was a very warm summer, actually. Again, very dry. This is why we're very worried about the water levels at the moment, because last year consistently for 3 out of the 4 seasons was very dry. And it was sunny, and these will be the things that you will remember from summer 2022, which were the probably, I would say, 3 heatwave events that we had early July, late July. Now, this was an exceptional heatwave, I would say. This was where the temperature in Plymouth got over 33, I think it was 36 degrees on the warmest day. So that was exceptional. Very rarely do we ever see a day in Plymouth that's over 30. And yet we had several days in this late July heat wave that peaked over 30. And then we had another unusually warm period in the school summer holidays. So this was another heat wave that came through. So, you can tell very easily at a glance, last summer was exceptional in terms of being warm and actually quite sunny and dry. And then going into... I've not done my animations very well at all, have I? So again, autumn was warmer. This is when the rain started coming back to us. Most of this is actually in November, so we're actually getting above average rainfall in the autumn, and then again pretty average rainfall. And again, you can see these warmer periods. There was quite a warm period pretty much all the way through October and into early November, and then a sneak preview. There was an exceptionally cold period just before Christmas. I don't know if you remember that, sort of the first couple of weeks of December. There was this very cold period, and actually I can't remember for quite a while actually now seeing temperatures pretty much down on at the minimum that have been recorded in that climatological period. So the last 30 years it was pretty cold for a relatively long period of time before kind of the warmth came back. So on average, the winter was, once you averaged it over those 3 months, this winter that we've just had was pretty average. So let's look at the wind conditions. So this is going right. Let's rewind back to winter 21-22. Dominant westerlies. So we had significant... So this is the windrows diagram. The closer you get to the edge of this is where you get the higher percentages of the winds in a particular direction. So this is about 20%. So 20% of the time, the wind was in the west-northwest, another 20% of the time in the west. So we're dominated by the westerlies, and where you've got the brighter colours, that's where you've got the stronger winds. So there were some significant wind events, which I'll talk about in a moment, with winds over 65 knots. Spring was much lighter winds, and we had, as you'd expect, and then the winds were very much more from a southeasterly direction, but pretty mixed, but not very strong. Then if we go forward to summer, westerly was slightly dominant, but again, it was pretty light winds for most of the summer, unusually so. And then as we pick up into the autumn time, again, we started to get some relatively stronger winds, but again, nothing really to write home about. There wasn't much in the way of storm activity last autumn. So in terms of storm naming, everybody gets quite do they? Maybe it's just me. Gets very excised about this storm naming. It does actually get very confusing, and I think the Met Office, the UK Met Office, were one of the first Met agencies to adopt this, but then a lot of the other Met agencies got involved, and that kind of leads to quite a lot of confusion. I think the way that we need to look at it is it's a risk register type thing that the government or the UK Met Office has done, such that it prevents widespread loss of life, damage to infrastructure, etc. So when a big storm might happen down here in the southwest, there aren't many of us down here. There's not much infrastructure, so therefore a storm may not get named. But anyway, in terms of the UK Ireland storms, last year we had probably the three which would be memorable were Dudley, which was the 16th to the 17th of February 2022. Eunice in particular, so this is where we had a red weather warning down here. There was 122 mile an hour winds at the Needles. And then Franklin, which came through and I think the unusual thing about 2022 storm season was how they all happened in really quick succession. So we had three storms that came through in under a week. And then there was nothing named in storm 2022-2023 season so far. So you might think you're wrong. There was a storm Noah that we had a couple of weeks ago. That wasn't named by the UK Met Office. It was named by all these other Met groupings. So the Southwest group did have a storm Mattis that was named on the 31st of March 2023, and then storm Noah, which was a couple of last week or about 10 days ago. Anyway, that's enough probably about naming of storms. I'll skip over that slide. And then in terms of what the wind speed and gust gave us so this was for at Rame Head. So we get hold of the data from the Rame Head NCI station, so you can visit the website. You can get hold of the data from there as well. This is where the three major named storms came through, and you can see that at Rame Head for Eunice we were getting gusts up to about 80 knots at Rame Head. And then our own weather station at Penley Point, we actually got a gust of 86 knots, so 98 miles per hour. So it was a pretty damaging storm. And if you think that the damage actually is proportional to the square of the wind speed, you get double the effect for a wind gust of 80 knots as you do for 60 knots. In terms of the wave height, so this is a wave height buoy that's at Loo Bay, so relatively sheltered. You don't get the wave intensities that, say, you get out at E1. Unfortunately, we haven't had the wave height data reliably from E1 recently. Again, you can see these three named storms coming through. But I think the thing to note is that they're not in any way exceptional compared with the rest of the year. So we've got time going along here. This is January, April, July, October, January. And you can see that some of the wind events that came through last autumn were, in terms of wave activity or wave power, pretty similar to what we were getting in these really big named storms, but they didn't get a mention. They didn't get named. So, just to bring home the point. Right, I'll eventually get on to doing oceanography. So this is what we had. These are our weekly observations that we have at station L4. So we've got temperature, top left, salinity, top right, oxygen, fluorescence, transmission, and par. So par is a level of the light that's going down through the water column. And things to note, so as you're getting warmer temperatures, so these are the redder colours here, so temperature up to about 17, 18 degrees last summer in the surface. And the things to note about the water column at L4, and this is really important, is that even though you're only about 4 miles offshore, 5 minutes, great, then what you find in the summer is that you get this seasonal stratification happening, and that happens between May and September of each year. And then you can also see at L4, even though you're relatively long way offshore, you can really clearly see the impact of the River Tamar outflow at L4. So this is where we get much lower salinities sort of going out to as far as that. The spring bloom, I won't talk about the plankton because Angus is going to talk about the plankton in a moment. And the spring bloom, according to the fluorometer data that we've got on the CTT, happened around about late April. It started off with something like a Phaeocystus bloom, which then forms colonies and descends down through the water column. That's kind of the way it happens relatively frequently. And then we get a sort of a chlorophyll or a phytoplankton bloom at around about 10 to 15 metres down for much of the spring and summer period, and then a very late summer bloom at the surface there. This is what the 2022 anomalies looks like. So just to give you a bit of orientation here, this is the entire time series in terms of anomalies from 1988 all the way through to now. So this is at surface, top left, 50 metres down, bottom left, and then the average is here in the middle. So this is the black line, so you get temperatures on average down to about 9 degrees at L4 in about late February, early March, and up to around about 16 degrees, 17 degrees in about August time. And then the envelope of variability, so this is one standard deviation away. Those are the two dotted lines either side. And the actual observations for 2022, again, show this really warm period that we have here. So we've got an average spring, and then these heat waves that kick through in July and August, really clearly shown in the time series. And then you can see when the temperature at 50 metres gets to be the same as at the surface, that's when you've got stratification breakdown, and the temperature throughout the water column is the same top to bottom. This is what's happened in terms of salinity. Salinity was very close to average pretty much for the entire season, but maybe there's a little bit higher salinities that you can see here when we had that very hot weather in the summer, which is down to very low river flow conditions. Okay, and then this is what was happening at E1 in 2022. So again, this is 20 mile further offshore. We only sample at E1 once a fortnight or once a month, and you can see again the stratification breakdown very clearly at E1. Pretty much an average spring. Also, there was a very cold observation that we made in April. We were right down to the average. I need to probably look at that data point again in some detail. And then again, you can see these July-August heat waves. Much longer time series at E1, right back to 1903. So pretty impressive time series there. And salinity is pretty similar to what we saw at L4. And then finally, I'll talk a little bit about the nutrients. So nutrients are absolutely critical for maintaining the biological activity in the Western English Channel. So this is a time series that we've been running for now just over 20 years. So just to give you an idea of the variability that we see, so nitrate varies between pretty much being below the limit of detection up to about 10 to 12.5. This is what happened in 2022. So in the winter we got up to about 7.5 micromole. In the summer, as you get the spring bloom starting, then the phytoplankton remove all of the surface nitrate, in fact nitrate all the way through the water column, and then it disappears very, very quickly over a period of about 2 weeks. By early May, you've got pretty much right down to the limit of detection. And then once you start the more unsettled weather in the autumn, then the nutrients get recharged to the surface. So that was the nitrate. And then for the phosphate, much lower levels of phosphate. Phosphate's about 1 to 16 ratio with, well, everyone will hang me for saying that, but 1 to 16 ratio with nitrate. We got we never really deplete the surface phosphate. This is what happened last year. So winter phosphate is about 0.6, which then again does follow a decline, but never really disappears entirely at L4. And on that, I will finish.